Okay, picture this. You're on a new team, right? And your first ticket seems super simple. Just add a button to the header, you click it, a modal pops up, easy. You code it up, you ship it, but clicking that button takes a full second for the modal to actually appear. What is going on? And more importantly, how in the world do you fix it? All right, let's get into it.
So this right here, this is our mystery. It's our crime scene. You click a single button and the entire UI just freezes for a whole second. And this isn't some weird, super rare bug. No, this is probably one of the most common performance headaches in React. So yeah, let's put on our detective hats and start investigating.
You know, if you look at the code, it seems totally fine. You've got your main app component, and it's got a bunch of heavy child components inside. All we did was toss in a little piece of state. You know, is modal open, and a button to toggle it. We all write code like this pretty much every day. But here's the thing. The problem, the real clue, is where that state lives. It's all the way at the top of our app.
Okay, to crack this case, we've got to go back to square one. We need to dig into how React really handles updates. We're about to uncover the truth about re-renders, and it all boils down to one single thing: state. So what even is a re-render? It's just React's way of updating a component that's already on the screen with some new data. It's way, way faster than creating a component from scratch because React is smart and reuses what it can. But here's the absolute key. Every single re-render without exception is kicked off by a state update. A click, a network request, you name it. If it changes state, a re-render is about to happen.
And boom, this is our first huge clue. When you update state in a component, React doesn't just re-render that one component. Oh no, it re-renders that component and then recursively re-renders all of its descendants. We're talking children, grandchildren, the whole family tree, all the way down. So in our case, because our state is way up at the top, our entire app is re-rendering, just to show one little modal. And that is where our 1 second lag is coming from.
Okay, now this is where we need to stop and bust the single biggest myth in React performance. A lot of us, and I mean a lot, were taught that when props change, a component re-renders, right? Well, it's just not true. Look at this. The reality is that a state change is the only thing that starts the process. The re-render then cascades down the tree no matter what the props are. It's the state update that's the trigger, not the props changing.
All right, so we know what's happening now. A state change kicks off this giant top-to-bottom re-render. But how does React actually pull this off? To understand that, we need to pop the hood and take a look at React's reconciliation engine. It's super powerful, but also super misunderstood.
So the secret sauce here is that there's no real magic. That JSX we all write every day, it's just a nice-looking wrapper. Syntax sugar, really. When it's compiled, every component just spits out a plain old JavaScript object. A simple object that describes what the UI should look like. We call these elements. And React's whole job is basically to take the new tree of these objects and compare it to the old one.
And this is the playbook it uses. This flowchart here is the diffing algorithm, and it's the heart of React's performance. It's how React avoids doing stupid, slow work. When that re-render gets triggered, React builds that new tree of element objects, and then it walks through both the old and new trees, comparing them node by node to figure out the absolute minimum amount of work it needs to do to update the real DOM.
And it does this with two really simple but super effective checks. First, it just does a quick reference check, a triple equals. If the object is literally the same object in memory as before, React just says, cool, nothing to do here, and skips that entire branch of the tree. That's a massive optimization. But if it's a new object, it then checks the component's type. If the type is different, like a div suddenly becomes a span, React just throws away the old stuff and mounts a totally new component. If the type is the same, it just updates the props. And then, you guessed it, it keeps going down to check the children.
Okay, so right about now, I know what some of you are thinking. Aha, I'll just use React.memo. I'll just wrap everything and stop all these re-renders. And yeah, that's a super common reaction. But hold on. Memoization is let's say, a fragile tool, and it's really easy to get it wrong. Let's find out why it's not the magic silver bullet we want it to be.
So what does React.memo actually do? Well, it's basically a stop sign for that recursive re-render we talked about. You wrap a component in it, and you're telling React, hey, before you re-render this component, just do a quick check. Have its props changed? If they're the same as last time, then just skip it. Don't even bother looking at its children's. Sounds awesome, doesn't it?
But here's the trap. This is where it all falls apart. Look at these two classic examples. That inline style object and that div we're passing in as children. Because of how JavaScript works, those are brand new objects getting created on every single render. So when React does its check, it sees a new object reference and it thinks, oh, the props have changed, and it re-renders the component anyway. And just like that, your React.memo is completely useless.
So here's the big takeaway. Memoization is like a chain. It's only as strong as its weakest link. If even one single prop is unstable, meaning it's a new function or object on every render, that link breaks. React.memo fails, the re-render happens, and the whole thing was for nothing. It's just too fragile to be the go-to solution for the big problem we're trying to solve here.
Okay, let's go back to our Crive scene. We've gathered the clues. We know that state triggers this massive recursive re-render. We know that memoization is a trap waiting to happen. So now, with everything we've learned, the real solution to our 1-second lag, well, it turns out to be shockingly simple.
And this slide just lays it out perfectly. Look at the before on the left. We've got state at the very top, and it's causing the whole page to re-render. It's slow. Now look at the after on the right. All we did was create a tiny little wrapper component that holds just the button and the modal. We moved our state into that wrapper, and now, when the state changes, only that tiny little box re-renders. All the heavy stuff underneath, totally untouched.
This simple but powerful strategy is called moving state down. See, instead of trying to fight against re-renders and block them, we're just controlling their size. We're containing the blast radius. By moving state as close as possible to where it's actually used, we shrink the re-render from the entire app down to just this one tiny part. And the result? Our modal opens instantly. Case closed.
So there we have it. We solved the mystery. The lag wasn't really a bug in the classic sense. It was just a side effect of not quite understanding how React's core mechanics work. So let's put all our findings together into a little detective's handbook so we don't fall into this trap again.
And here it is. This is your new mental model for building fast React apps. It all comes down to these core principles. We've seen it firsthand. State flows down, and that's what causes re-renders. We know JSX is just objects, and that reconciliation checks the component type first. That's the key reason you should never define a component inside another component. It'll get remounted every time. And yeah, one last thing. Keys are for keeping track of items in a list. They're for identity, not some magic performance trick. Once you really get these mechanics, performance isn't something you bolt on at the end. It just becomes a natural result of writing good, clean code.
So in the end, this whole mystery wasn't about magic at all. It was about mechanics. We didn't need some clever, complicated hack to fix it. All we needed was to understand the rules of the game we were playing. And that leaves me with one final question for you to think about. What's something in your codebase that feels like magic right now? That's really just a set of mechanics waiting for you to investigate.